So normally when we're looking for a limit, we just try to jam the x value into the function. But if we end up getting like a 0 over 0, that means that we've got to do something algebraic to the problem, and then we can go ahead and jam our x equals 1 in. So for this one, if I jam the 1 in, I'm going to get 2 minus the square root of 4, which is 2. 2 minus 2 is 0. And on the bottom, 1 minus 1 is 0, which means I got to do some reducing here, or figure this out. And usually when you see a radical in the problem, like we have here, you're going to probably want to think rationalize to simplify. So the radical and rationalize, the r's go together. I multiply top and bottom by the conjugate. And now you got to remember what a conjugate is. Same terms, opposite sign in the middle. So we got this going on. Remember, our goal is to multiply the conjugates together and leave the other part factored. So we're going to leave the denominator here factored. And I know you like to bring down limit as x approaches 1 of. So now we're going to FOIL here. So when I FOIL, I'm going to take the first times the first, 2 times 2, and the last times the last. A negative. Now be careful here because this is x plus 3 times x plus 3. The radicals are going to drop. And I'm left with just x plus 3, but I got to put that in parentheses because that negative is negative the whole inside of the radical, not just negative the x. And then on the bottom, everything's the same. Don't FOIL. Right. Distribute the negative on top and see what you've got. Hopefully it'll cancel out with something on the bottom, and that's the whole goal. If it doesn't, then you probably have done something wrong. All right, so if I distribute the negative, let's see, I'm going to have 4 minus x minus 3. So that's the limit as x approaches 1 of a negative x plus 1 over x minus 1, and then that funky radical thing. Now as this stands, you can't cancel, but it looks like if I factor out the negative 1 out of the top, I am going to be able to cancel. So factor out a negative 1, because we don't usually like to have a negative in front of our lead term anyway. So it's going to be x minus 1. Distribute it back through. Make sure you get negative x plus 1. This works out good, though, because now it will cancel with my x minus 1 on the bottom. So I have the limit as x approaches 1 of negative 1. The x minus 1's cancel, and I have on the bottom 2 plus square root x plus 3. Now try jamming in the number 1 and seeing what you get out. So if I jam in the number 1, the limit's going to be negative 1 over 2 plus square root of 1 plus 3. So that's negative 1 over 2 plus 2, negative 1/4. All right. I kind of had a feeling the x minus 1 should cancel out because when nit's gone, then when I jam in the 1, I'm not going to end up with a 0 in the denominator anymore. So that kind of is my clue as well, that that x minus 1 should cancel. All right. Let's take a look at one more here. You got the limit as h approaches 0 minus 5h plus 1 squared over h. So your first, again, method is jam the 0 in, see what happens. Well, if I jam the 0 in, I've got a 0 in the denominator. That's never good. And 0 plus 1, do order of operations, that's 1 squared. 1 squared is 1, times 5 is 5, and 5 minus 5 is 0. So you end up with 0 over 0. That's not good. So you got to think, okay, well, there's no square root in the problem, so I'm not going to multiply by a conjugate here. That's really saved for when I'm doing radicals. All right, so no radicals, no rationalizing. So the next thing I'd probably try is let's multiply out the numerator and see if we can get stuff to cancel. So limit as h approaches 0 of, now there's nothing to do on the denominator, but watch this. You can't take 5 minus 5 because you got to do multiplication before you do subtraction, and you can't do multiplication until you square this h plus 1. So you're going to have to FOIL h plus 1 out. All right, so this is going to take a little bit of work. 5 minus 5, and now I'm going to FOIL, so I'm going to put it in parentheses, FOIL this out. H squared plus 1h plus 1h plus 1. That's first, outside, inside, last. All right. Distribute the negative 5 all the way through, and we'll see what we end up with here. So I still have the 5 minus 5h squared minus 5h minus 5h, negative 5 times 1, negative 5 over h. Combined up your like terms, and let's see what happens. So 5 minus 5 will cancel out. I have a negative 5h squared. Minus 5 is minus 10h divided by h. Now, if I stick my 0 in now, I'm still going to get 0 over 0. So something's still messed up. But what you can do is factor. And for this one, if I factor out, let's see, they both have in common a negative 5 and an h. And this is the limit, I forgot to put that in, as h approaches 0, of negative 5h. So I'm going to be left with an h plus 2 over h. Always distribute it back out. Make sure you get back what you started with. Cancel the h's. And I have the limit as h approaches 0 of negative 5 times h plus 2. The h is gone now out of the denominator. So when I jam my 0 in, I can just, 0 plus 2 is 2. 2 times negative 5, negative 10. So factoring in this case was a good thing, but before I could factor, I had to multiply it all out, combine like terms, then refactor it and cancel. Kind of like what you did on the previous page. Factor, cancel, jam your number in.